we're going to use the intuitive way to figure out this limit. And we want to use the rule of one set limits must be equal, then the value will be the answer of this limit. Let's say we first start by use this function notation to represent this rational function, because later on we're gonna write the limits. It will go crazy to write this whole chunk. So we start by defining this function. Now we want to test the one set limits as x approach to -3, because here is approaching to -3. We want to start by testing the x value star from the left hand side. We put this negative bar here, and here's the function to represent this rational function. Then we want to figure out what does that function equal to. The first thing we want to do is to by constructing a table. Here's the function. Since the limit tells us there's -3, and here's the whole, the x value want to approach to this -3 but never become -3, never cross it. It could be star from the left hand side or the right hand side. So since we want to start from the left hand side, why don't we pick a value that is really near to -3, and that value would be -3.1. So it could be right here, and we gotta figure out a few numbers and the approach to -3. So it will be -3.01, -3.001, -3.0001, and you may continue if you want. So to figure out the function, we simply replace the x value back into this rational function, and then you may use the calculator to figure out the corresponding y value. So in this case, I'm going to give you that value because it might take a lot of time to figure out that. So -0.491803. And the second one is 0.499168. So as I write these numbers, you may want to see the trending, what the pattern is. So 99917. The last one is 0.499992. You may want to see those numbers. So as x value becomes smaller and smaller, this y value becomes larger and larger. And you may see this 4918 becomes 991, becomes 999, and becomes 9999. It becomes larger, but it seems like it want to approach to some number but never become that number. So why don't we help them for a bit? Since here's the 4 and here's the 9, why don't we round it for a bit? Like -0.5. And it's also equals to -1/2. So that value is the answer for this one set value, starting from the left hand side. Again, similarly, we want to figure out the limit from the right hand side. We put this addition mark. Here's the function. What does that equal to? So we start by constructing the table. Here's the function. Since here's the whole, we start from the right hand side. We want to choose a number that is really near to -3. So that number could be -2.9. So it might be right here. But we're going to choose multiple values. So to approach this -3, so it might be -2.99, negative 2.999, and negative 2.9999. You may start to write a few more if you want. And the function, same thing, you put the x value back into the function, and then by using calculator you can figure out the corresponding y value. So in this case, negative 0.508475. Here's another value. And here's the last one. As you can see, as the x value becomes larger and larger, the y value becomes smaller and smaller. Here's 0.8, it becomes 0.0, and it becomes 0.0.0, and it becomes 0.0.0.0. So it seems like the y value want to approach to certain number but never become that number. So to help them for a bit, here's a 5, here's a 0. We'll round it for a bit, 0.5. So is 0.1. I mean, negative 1/2. And that's the answer for this limits, one-side limit for this right-hand side. And because the limit as x approach to -3 from the left-hand side equals to this one-side limit from the right-hand side, they are both equal to -2. I mean negative 1/2. So we may conclude it that the limit as x approach to -3. This time we don't put any bar here or addition sign here. That's the actual limit of this function equals negative 1/2. But remember, we use the function notation to represent the rational function. We're going to make sure to write it back. So the function will be 3x plus 9 over x squared minus 9 equals negative 1/2. And that's the final answer.